This is the solving quadratics review. We are in the discriminant section now. It says find the discriminant, state the number and the type of roots, then state if the quadratic would be factorable based on the value of the discriminant. So, reminder here that b squared minus 4ac is our discriminant. It will not be provided for you, but the quadratic formula will be provided for you. So if you look back at one of the problems that we did previously, here's the quadratic formula at the top right of your screen. Can you identify where the discriminant comes from? And I hope that you can. But as we look at problem number 14, just a reminder that A is 4, B is -2, and C is -10. And when we look at this, we're going to fill in that formula, so we end up with -2 squared minus 4 times -10. And we get 4, and then 4 times 4 is 16 times -10, which is -160. And double negative gives us positive, and I'm going to pull up the calculator on the next one, but we get 164. That's our value for our discriminant. Well, then we ask ourselves, because it's a positive value here, is 164 a perfect square, or is it not a perfect square? And what we figure out here as we start thinking about things is that this is not a perfect square, which means that we're going to have two irrational roots. And whenever we get irrational, we cannot factor. But as we look up here at the graphs, between A, between B, and between C, we need to have two roots. And on part A, or graph A here, this graph crosses the x-axis twice, so this is going to be A. Number 15, same thing. Identify the fact that A is 1, B is -5, and C is 7. And fill in B squared minus 4AC. So we get -5 squared, and you do want parentheses around there, minus 4 times A times C, and this time we'll type that in the calculator. Again, you want parentheses, -5 squared minus 4 times 1 times 7. And when we type enter here, I need to check I typed it in wrong. Try it one more time. -5 squared minus 4 times A times C. I just didn't get that times in on that one, and we get the value of -3. So our discriminant here is -3. As we take a look at this, we know when our value of our discriminant is negative, we're still going to get two roots. But in this case, what's going to happen is there are going to be two imaginary roots. And when we get imaginary roots, again, we cannot factor. And what our picture looks like when we get imaginary roots is that it will not cross the x-axis. The graph will not cross the x-axis. So we're going to have a value of C here in terms of our graph. Lots of practice on these types of problems here. We've got our pictures, and we want to identify what A and B and C are. I left myself a little bit more room on 16 and 17, but A is 3, B is -6, C is 3, and we're filling that back into the discriminant, and our discriminant is going to be -6 squared minus 4 times 3 times 3. So we pull up our calculator, and we have -6 squared minus 4 times 3 times 3. You can check real quick to make sure I have it typed in right. It's 4 times 3 times 3. And we get 0. Well, 0. When our discriminant is 0, we end up with only one root. We only cross or touch the x-axis once, and it is rational. So if we look back up here at our graph, since we're thinking about it, the only graph where it crosses once is graph B. And when we get a rational answer, we can factor. So yes, we can factor. Number 17, 6x squared plus x minus 35. A is 6, B is 1, C is negative 35. Fill in the quadratic formula. Sorry, fill in the discriminant. B squared minus 4ac. The discriminant comes from the quadratic formula. Well, we get 1 squared minus 4 times 6 times negative 35. And we'll type that in. 1 squared minus 4 times 6 times negative 35. And we get the value of 841. And it seems that I got a little bit tricky on this one, because the question with this is 841 a perfect square? And I don't know right off the top of my head that it is or isn't, and you probably don't either. So when we don't know, let's type in the square root of 841. And we get 29. We don't get a big long decimal number here. We get simply 29, which means that it is a perfect square. Don't write the square root here on the problem. Our discriminant is 841. It is a perfect square, which means that we're going to get 2 rational solutions. And again, whenever we get rational, that means that our quadratic is factorable. And then we're going to pick the graph that crosses the x-axis twice, which is going to be A.